All right, so paper 2. So first one right here, you got it says that she claims that rabbits in Australia have longer ears than rabbits in Spain. To test her claim, she randomly selected a sample of rabbits was collected in each country. The length of each one of the ears of the rabbits was measured, and the value recorded correctly to the nearest millimeter. In Australia, sample the median recorded was 80 millimeters, and the interquartile range was 11. And then the recorded values for the Spanish sample are shown here. And so, what did you say? I like this one. This was pretty easy one to start with. What did you say was the median for here? 75, yeah. So 75 for the Spanish ones. And what was the interquartile range? 16. Okay. So 75 being that one right there. And I believe on the actual one that's been copied a couple times, so it just didn't come out. There was like a graph grid or whatever, so it was really easy to read there. And so this is 68 to 84, and that's difference right there was 16. Okay? Man, that was probably the easiest 3 points on the test right there, huh? All right. I'm not sure why they gave the 3 points on that, but that was nice. All right. I think because the median was just probably worth 1. The IQR was probably worth 2 because you had to like go find 2 things to subtract. So it had a little bit extra work. All right. Justify your answers. Justifying your answers, compare the distributions of the lengths of the rabbit's ears in Australia and Spain using the median. So what would you say about the median?
It's less than the median for Australia.
Okay, so Spain is less than Australia. So what was her prediction? That Australia was going to be bigger or whatever?
Yes.
All right. So I probably would have said something like her prediction was correct as far as the medians goes because Australia is 80, which is greater than the 75 for Spain. Something along those lines there, saying that one's bigger than the other, and so it's kind of supporting her claim. All right. How could we use the interquartile range to support her claim? What does the interquartile range tell us?
Well, the data's more spread out.
Okay, so on Spain, the data's more spread out. This one's more condensed, so it's condensed and higher, so I would think that it's better there. Yeah, it's more, I kind of said it's more accurate, right? That Australia is more accurate because the data is less spread. More accurate. Because IQR is smaller. Something along those lines, but you needed to write something out there. That was worth 4 points. I'm guessing 2 for each of those and just having a justification to go along with those.
Okay.
Good? Go on that one? All right. Number 2. Darren buys a car for $35,000. The value of the car decreases by 15% in the first year. So the value of the car, I simply did this right here. I multiplied it by 85% because that's how much they retain. That's that 1 minus 15%. And got, sorry, right over here. It's 29 something or another, right?
Yeah, 29,750.
And I think that rounded to a nice whole number as well, if I'm not mistaken. And they do talk about the nearest dollar down here. So 29,750 is what I got. So that was worth 2 points. Again, I think that's a pretty easy 2 points there, hopefully. All right. After the first year, the value of the car decreases by 11% each subsequent year. Then finally, the value of Darren's car after he buys it, 10 years after he buys it, giving you an answer to the nearest dollar. What'd you do here?
Took the number we got from A and made that the initial value.
Okay, so that's technically my new initial value.
Yeah.
This time I'm doing 0.89 or 1 minus the 0.11. And I'm going to do this for how many years?
9.
For 9, not 10, because I've already done the 1 year, right? So that's exactly what I did. I did that. It did have a little bit of change on this one. And so I got that right there as the answer to the nearest whole number, the nearest dollar. Everybody okay with that one? Not difficult, but it's got that one little twist in there. You gotta be careful. Okay. Then it says, okay, when Darren has owned the car for incomplete years, the value of the car is less than 10% of its original value. Well, what's 10% of its original value?
3,500.
Yeah, just basically move the decimal one place. So 3,500 equals,
That's greater than.
okay. I did equals, but you could do greater than, yeah.
Okay.
All right, so this 3,500 is greater than, I use this formula right here. Okay, I use that and use this because that explains most of the problem. Knowing that I'm gonna have to do what? Add one extra year for this piece that I did up here. Okay. Put it in the calculator if you'd like. You'll have to probably expand your window. I did log to solve it because I just divided by this right here. That went pretty evenly. I remember when I did that in the calculator. I think that was 2/17. Again, you could do this a couple different ways. You could graph that, graph that. Matter of fact, if you want to, I would have divided by 29,750 and then go graph, because then you don't even have to change a window if you graph this. All right, that's the nice thing about that. But if I were to finish it, I did this in log. So I did log 0.89. And then the n comes over here, and the 2/17 goes there. So I put that in my calculator. You can graph, you can do log, either way. Okay. I believe I got like 18.23 there. Now this is why I was speaking about a while ago. I use equals versus using greater than, because if I switch this around, technically I got to be careful with the inequality. It could flip and stuff like that too. All right, here. Knowing that. I'm going to use a range, so to speak, because this is not going to be 100% right, because I can't have 18.23 years. So if I'm thinking about this situation, they're equal at 18.23, but I have to go to 19 to be less than. But not only do I have to go to 19, I have to go that one more from the top. So it's going to take 20 years for me to do this. It's a pretty good one for question 2 already. All right, got a little twist in there. Not awfully hard, but it was a little bit unique. But they're bringing some logs or bringing some graphing in there. And again, you'll have your calculator to do that however you want to do that. Question?
Why did you, on part B, so why did you have the exponent be 9 instead of 10?
Because I'm doing 10 years, but this is already after 1 year. So I did question A, which handled the first year. All right.
Oh.
So then I only had 9 more years to go. Good?
I get it.
Mm-hmm. All right. All right. This one right here. So you've got this monument that's in the shape of a cone. And we're trying to find the radius of the base, and then we're trying to find the volume of the monument. And the volume of the monument is going to be part of your formula sheet. I have to go back and get that. Where did you start with this?
So you have the middle line, the opposite line, and that'd be 20 minus 1.8. So
Yep.
it was 18.2, and I just use tangent.
Good.
Integration.
So that's the triangle I'm going to work in. So you're correct. 20 is the entire height. The man is 1.8, so that puts this as 18.2 is that side right there. I'm looking to find this whole length right there. Then I'm going to take a 5 away from it, and that would be my radius. And you're correct in stating that that was tangent. So tangent of 58. Now be careful when we're using our calculator. What's got to be true in our calculator? Since it's in degrees, I got to flip the degrees. Now I caught myself on this a while ago because I was working in degrees. Then I had to go back. A couple other ones here in a minute. I got to go back to radians. So just be mindful of that. Anytime you're using any kind of trig, you got to think about which one you're in. All right. So I did that, and I believe that was like 11 point something.
Yeah, 11.4.
11.4. Yeah, 11.37 is what it was, and I did that because now when I subtract 5, then my 3 significant figures wouldn't be 6.4, it would be 6.37. Make sense?
Mm-hmm.
All right. So I would leave that whole length in the calculator as long as I can, because I know I can subtract 5 and go from there. Go. Same thing. the answer that I used in the calculator, I'm gonna end up using in part B as well, because I gotta find the radius for that to find the volume. Volume for this is, coming from that formula sheet, 1/3 pi r squared h. So 1/3 times the 3.14, I used my pi key, and I used the 6.37 squared there, and then the height would be 20. So multiply, that's definitely a calculator problem there. Multiply all that out. I got 850.54, so if we went 3 significant figures, it would be 851 meters cubed. Know what you got? Pretty close to that.
Yeah.
And I think there's probably a little bit of a margin of error there. I think you would have 850 would probably be an acceptable answer, because if you use 3.14 instead of like the entire pi, or if you rounded your decimal a little bit as well. Let me look real quick. This is what they call the mark scheme. I don't know if y'all have done that in any other class and stuff like that. So see right here, they say this is worth 2 marks is what it says. So the answer's worth 1 mark, and then some type of method is worth the other mark. So you'd only get 1 point on this one is what they're saying if you didn't show some work. And they said except 849.84, which would be 850, because you use 6.37 instead of like the whole thing out. So they're gonna work a little, you've got a little bit of a margin of error in there, all right, as you're rounding and things like that as you're going. I like to keep the whole one because I think that's more accurate and it's gonna keep me on the right track, where if I were to round too much in a problem, then I could find myself off. Okay. Next. All right, so this is the one that you skipped a while ago. You said, all right, so let's talk about normal distribution. Just go over it real quick because we haven't done much of it. Now, you won't see this on this one because it's not non-calculator, this is calculator. But remember, this is my mean right there, and this is a nice symmetrical graph. So how much data is on the left-hand side and right-hand side of the mean? 50 and 50, all right? We have 1 standard deviation up and 1 standard deviation down. So if I went 1 standard deviation up, 1 standard deviation down, anybody remember that empirical rule, what numbers go there? There's 2 numbers that you have to memorize on the 68 and 95, okay? So 1 standard deviation between the 2 purple lines here would be 68% of the data. So you could split that into 34 and 34, but 68 is the number that you need to remember, okay? It's not on the formula sheet, you'll need to know that, okay? Now, I don't need to know that in this case right here because this is in the calculator, right? But it's good kind of knowledge as we're going as well, right? If I were to go 2 standard deviations, another standard deviation, another standard deviation, then the whole thing from blue line to blue line would be 95%. So that would be 0.475 and 0.475 if I split that evenly. There is a third one, it's like 99.7, but I hardly ever see them use that one. It's normally the 1 and the 2, which would be 68 and 95. Okay? Now, let's go to this right here. X is normally distributed with a mean of 10. So a mean of 10, a standard deviation of 2, so that's 2, so that would be 12. This would be 2, so that would be 8. So technically what I was saying a while ago, between 8 and 12 would be 68% of the data. Okay? If I went another one, that would be 14 and 6. So between 6 and 14, that would be 95% of the data. Okay? Now, on this one, I know this is a calculator problem because they got off of a deviation. When you're doing it by hand, you can only have 1, 2, 3, 4. You can only do those. You really can't do the 1.5s. Now, technically, how much would 1.5 standard deviations be? 3, and b value 3. Because the standard deviation is 2. If I multiply it by 1.5, then that would be 3. So we're talking about 13 is that number. All right, so they didn't give me the number up front. That's what was a little bit tricky about this one. They didn't give me that value 13. And where they want to know, what's the probability that I'm more than 13? Okay. So I wanna know this area right there. I'm gonna go to my calculator and I'm gonna perform that in the calculator. So let's kind of review how to do that in the calculator. So we talked about binomial distributions the other day. So if I were to do this on new, I don't want that. I'm just gonna be on my normal calculator. We talked about binomial distribution, so I can get there with probability or statistics, all right? So we're still in distributions, but it's not binomial, it's normal this time. So I'm gonna go there, I'm gonna go distributions, and then I have normal CDF and I have inverse normal. That's the two that we'll use for standard deviation. Excuse me, for normal distribution. So normal distribution, I'm gonna pick this one right there. Now, what am I wanting in this case? I'm wanting from 13 to where? To infinity, right? So the nice thing about this, it reminds me of my notation for infinity. That's what's there. But I don't want negative infinity. I'm gonna put 13 on that one. And then I'm gonna put 9, E, 999. So that's the positive infinity. My mean is 10. My standard deviation is 2. And so I have all that into the calculator now. Okay? Once I hit enter, it's gonna post that there, and there's my answer. So my probability would be 0.0668 is what the three significant figures would be. Okay? Next. Actually went too far on this one when I was working a while ago. The probability that X is more than K standard deviations above the mean is 0.1. All right? Where K is all real numbers. There's an element over. Find the value of K. So if I were to draw a picture of this again, so that's 10, and then I want X, find the probability that X is more than K standard deviations of the mean is 0.1. So more than is 0.1. So X would be here, and this right here, all right, is the 0.1. The number of standard deviations above the mean, we also refer to that as z-score, all right? And the way we find z-scores, we're taking whatever the normal distribution is, and we're standardizing it. We're making a mean of 0 and a standard deviation of 1. So what I'm gonna do here, they've given me the area this time. And so when they give me the area, I'm gonna use inverse normal. So I'm gonna go, same thing, I'm gonna go find my distributions. All right, instead of using normal CDF, I'm gonna go do inverse normal. Now be careful here, the area that I have to put in here is the area on the left-hand side of the graph. All right, so I'm not gonna put 0.1. If I put 0.1, that would give me the far left edge of the thing. 0.1's on the right, so the area I need to put in is 0.9. Okay, now if you put 0.1 in here, you would get the correct answer, but you would get a negative version of it because it would be a negative standard deviation instead of a positive standard deviation. So technically all I have to do is this. I'm gonna leave the 0s and 1s in there, all right? And there is my value. So 1.28 is how many standard deviations above I would be. Which kind of makes sense because if I went 95, that would be 2 standard deviations above, correct? How much would be left right here if it was 2 standard deviations?
It would be 5.
5%, that's divided evenly, correct?
Yeah.
So that would be like 0.025 right there. Well, we're wanting 0.1, so we know 2 is too far, all right? 1, if I put 34 there, then that would be 0.16, which that's not quite enough. So we know it's somewhere between 1 and 2. That kind of makes sense to us. Now, I took this a step further because I misread it at first, because a lot of times I'm wanting to know not what the K is, but I'm wanting to know what this X value is. What is that X right there that goes there, all right? So you do have a formula on your formula page that states that the z-score is equal to the x minus the mean over the standard deviation. That's your z-score, all right? And so to solve this, if they were asking about x, which a lot of times they do, this was a little bit, I guess, a little bit lower level question, not a lot. But the z-score we found was the 1.28. The x is what we're looking for. The mean is 10, and our standard deviation is 2. So we could solve for that actual x value, what would be there. It didn't even say what these, there's no context in this problem, is there? There's not a word problem. Normally they have a word problem to go along with it, so it just kind of means a little bit more. But I just wonder, we hadn't gone over that yet. That's what we're gonna do on Monday probably. And so, because we hadn't done that in topic 4 yet. Okay, good? All right. Number five is calculus problem. Particle moves in a straight line such that it passes through a fixed point O at time 0. And where t represents the time measured in seconds after passing O, for 0 to 10 seconds, its velocity, meters per second, is given by this. So what is this representing? I heard some of you talking about that a while ago. What's the velocity represent? That's the first derivative. So we're seeing the first derivative graph here is what we're seeing. Okay. So find the smallest particle of t when the particle changes directions. How do we know when it changes directions? When it crosses the x-axis. I'm going from a negative velocity to a positive velocity, so I have to pause just for a minute to change directions. So there's the first time it changes directions. There would be the second time it changed directions, but what they're asking for is that right there. So what I simply did here, I'm not going to do it in the calculator right now, trust that you could do that, is I'm going to take this and I'm going to go plug that in, and I'm going to graph it, and I'm just going to find a 0. Okay? So that 0 that I found was 1.69. All right? Everybody okay with that? So finding the 0 there. Next part, the displacement of the particle is measured in meters from O, or from 0. Find the range of values for t which the displacement is increasing. Where's the displacement increasing? When it's above the x-axis. So we already found this one, correct? So we need to go find that 0 as well. So I'm finding another 0. So that one I got a 6.12. So the range there was in between those two values. So in between those two values, the displacement is increasing.
Could you have also subtracted them and just gotten the
I did that as well, and the way that it phrases it, I think you would have probably gotten points for that.
but it wouldn't have been correct.
I think they would have asked more of like how much time is it increasing?
Oh, okay.
See what I'm saying? Then I agree with you, then you'd probably subtract them, all right? But it's just saying when, what value's there, all right? Find the displacement of the particle relative to O when it's equal to 10.
Well, we didn't do this for it.
What is displacement?
It's gonna be the
original.
It's the original. So how do I get from the first derivative or the velocity back to the original? Antiderivative. All right. Now you can do it by hand. All right. And I started doing that. What am I doing? All right. Because in my calculator, by the way, I do need to be in radians here. All right, on this problem. There's no degrees mentioned in this problem at all. So if I'm not sure radians or degrees, I'm always going to default to radians unless it specifically says degrees in the problem. That's where I would do that. Okay. So I need to be in radians here, and so I'm going to go menu, go to my calculus menu, because I know that's calculus idea, and I'm needing to find the antiderivative or the integral, all right? So the bounds here, I'm going from 0 to 10, all right? And then I'm gonna type in the value, the equation I have, 2 sine, we haven't reviewed this, it's been a couple weeks since we did this, 0.5 x, and then was it plus 0.3 x, and then minus 2, and then dx. Okay, so if I did that, I got that right there, and that's where I'm located.
Are we gonna go over like anti-derivatives without the calculator?
Yeah.
and everything?
And so let's talk about that right now too. And so if I wanted to do this without the calculator, let me look at something real quick. So it said in here, just want to revisit what it said. So it says a particle moves in a straight line through a fixed point O. Doesn't tell me where O is. All right. And so I was hoping I could do it a little bit simpler, but I can't really do that. So if I was going to do the antiderivative here, antiderivative of sine is cosine, but it's also a negative. All right. I've got this 2 here. And then if I think about this, this is a chain rule. So there's a 0.5 t in there. But what I would have done is I would have multiplied by the 0.5 out here when I did chain rule. So I'm gonna have to divide by 0.5. Dividing by 0.5 is the same thing as doing what? Multiplying by 2. So this is really -4 cosine of 0.5 t. I think that's the hardest part of that antiderivative. Then I go 0.3, this would be t squared, and I'm gonna divide by that. Again, I don't really like the way that looks, but I'm just gonna leave it there for now. Minus 2t, and then plus c. Now, because I don't know, if I knew the exact location of where it started, if I knew that value, then if I plug 0 in, then 0, 0, 0 kind of idea, all right? Actually, the 0 in here, the cosine would be a -4, right? Because cosine of 0 is here. So that would be 1 times -4, but that would be 0, that would be 0. But if I knew where it originated, then I could say it equals to, if they said 5 or something like that, then I could put that there, and I could solve for c. Then I can plug my 10 in, all right? For what they've given me right now, because I don't know what c is, I'm just finding the difference from where I started to where I ended. That's why I'm doing from 0 to 10. So 0 where I started, 10 where I left off. What's the displacement between those is what it's saying, okay? And so I would evaluate this integral now from 0 to 10. So I'd put 10 in here, which that's not, well, that's not too, well, it's 5. That's not gonna look good there. I'm gonna have to have my calculator do that anyways, all right? It's not a reason, but I'd put 10, I put 10, I put 10. We know that the c's are gonna cancel because we're subtracting. And then I go back and put 0 in, and that's how I would do that by hand. It'd be a much easier problem, kind of like what we did, you weren't here. We talked 7th period yesterday. We had one from the previous test paper 1 that was very similar there, but it had numbers and values that were a little bit easier to plug in. Okay? Good on that one? All right. This one right here, and I need to make sure that I go over this one with everyone. They've been doing more of this bivariate stuff over the last couple of years, and I need to make sure that I do a better job of explaining what's going on here with you as you're going. All right. So yes, I do have to put that table in. All right. I may do that here in a second, but they kind of helped me a little bit on this one. I really don't need the table. Yeah, I need it for A, and then I'll need it for the very last part of C, but I don't need it in between. So I've got to plug that in. Let's do it real quick just so I have it, and I can I do that with you guys. All right, so I'm gonna go control doc, and I'm gonna go add list and spreadsheets. I'm gonna go X and Y. All right, so here we go. 52 and 71, 100, 93, 81, 80, 8, 100, 70, 61. And 58, and 80, 92, 8, 90, 82, 100, 74. All right, sorry. All right, so now gonna run the regression on that. So I'm gonna go actually I'm gonna go back over here and I'm gonna run the regression here. So I'm going just on my normal calculator menu, statistics, and I'm gonna go stat calculations, and I'm running linear regression. X and Y. Leave the frequency list alone. And so the R value here at the bottom, that is my correlation coefficient, or Pearson's product moment correlation coefficient. All right, so 0.901. All right, it's pretty easy, 2 points there. You just got to do a little bit of work to get it, but it's not super hard work. Okay. All right. So on the next part of this, by the way, I kind of like this because I hate missing points on this because I typed in a wrong letter, correct? Mm-hmm. And so you could basically double check your work to make sure I got that, to make sure I didn't type in anything incorrect, which is kind of nice. I like the fact that they did that. Okay. So it said that Giovanni was absent for test A and Paulo was absent for test B. The teacher used the regression line of Y on X to estimate the missing scores. So Paulo missed, he was there for test A, but he was not there for test B. So we're going to use A to prove B. So they're going to do this right here. By the way, would you like, I don't know if I'd like to have a score like this. I don't know, maybe. Not necessarily. All right. Give a reason why this method is not appropriate. What did you say? I know I heard you talk about it a while ago. It's not in the data set. 10 is like kind of an outlier. It's really, that's what you all were talking about a while ago. It's very far outside the data set. So if you were to look here, the values in the data set, the lowest value for test A was 52 and the highest was 100. The lowest value for test B was 58 and then the highest was 100. So it needs to fall in that. And if it does not fall in that, we call that extrapolation. That's correct. Now, if you did not remember extrapolation, I think you could say that it's an outlier, it falls outside the data range. I think that would be an appropriate explanation. All right, it's only worth 1 point. There you have it. Now, Giovanni scored a 90 on test B. The teacher estimated his score on test A to be 87 to the nearest integer using the following calculation. So what they do here? That's basically the Y value, right?
Oh, yeah.
Plug the Y value in to get the X. Now, this is a spot that I don't know that I gave you enough information here, and let's talk about it just real quick. Because it says, why is this method not appropriate? Any thoughts? Seems appropriate, right?
Yeah.
Not a big deal.
But maybe is it because the R value is only a 9, a 0.9?
Still pretty good though, right?
Yeah.
All right. Now here's the reason why. Here's what they're wanting to say. So this equation right here, that part right there, that equation is the equation Y on X. So we've ran the regression of Y based off of X. So Y, we can get Y's because we have the X's, all right? So what we need to do to get this, we need to switch it and we need to run X on Y, all right? We need to go X on Y. So how do you do that? And so all I'm doing there, because by the way, I mean, I label them test A and test B, but could I do test B and test A, just switch them? All right, and so if I was gonna do that here, I would do, same thing, menu, statistics, stat calculations, linear regression. And all I'm gonna do here is gonna make X or Y the independent and X the dependent.
Is that the same as finding the inverse?
It's kind of the same as finding the inverse. They run the regression a little bit differently. I'm not sure. I'd have to look at it. I don't know that it's the inverse all the time. But yeah, so we technically want to use that equation because I'm plugging into the X to get, when I'm doing bivariate data and I'm running the regression, I'm basically saying that X is related to Y this way. So anytime I get X's, that's fine, I can plug in. But if I get a Y to solve it backwards, technically we should have run it the other way, ran X on Y, and then plug the Y's in, basically to get that. So that's the deal. I did not teach that. I felt bad, because this last year's test, I felt bad because I didn't explain that to that group enough, all right?
Wait. Okay.
So when we're running the regression, you have your independent, you have your dependent variable. So your independent variable goes in the equation and your dependent variable is the result, all right? So you're able to use that regression equation if you put the input in and they get the output, that's fine. But if you switch it and you take an output and try to go find the input, technically that's not correct. You should have switched them and found a new equation. Make sense? So normally when we do a regression, we're normally doing the regression of Y on X. That's normally how it works, okay? But in this case, if I had a Y value and I was trying to solve for X, then I would switch that. I would do X on Y. And so that's the explanation that they're wanting for part 1 of that, okay? And now that I have this equation here, now I would plug in the, 90? Now I would plug the 90 into here, so 90 times the 0.87 or 0.987 or whatever, and then go from there. So I think your show that on this is showing this new equation, is what you would get. Okay? Yeah, I was disappointed in that last year. All right. You want to take a quick break?